Yes, it's time for Aditi.
Thanks for the introduction, Fanbo. Okay, so basically in this talk, I'll probably help you understand how to break into the world of machine learning. And I'll also use like one of my real life project examples, which I did as a machine learning intern in Blue Canoe Learning in Seattle. So probably that would help you understand how our machine learning projects structured in the real world. And then towards the end, I'll just give you a few interviewing tips, and you can stop me whenever you have any questions, or I'll leave some time towards the end for questions as well. Okay, let's begin. So I'll start with a brief timeline about myself. So I finished my undergraduate in 2013 from NIT Jalandhar in India. Post that, I started working for a firm called ZS Associates as a business analyst, which is basically a pharma consulting. And then I worked there for about 2.5 years before moving to a company called WNS Global Services in Bangalore, where I was working for an insurance client as a data science manager. And after that, I moved to the US as a graduate student at University of Washington, Seattle, where I basically finished my master's in data science. And along with my master's, I was also interning in a startup called Blue Canoe Learning here in Seattle. And post my internship and my graduation, I started working for Microsoft as a machine learning engineer, where I'm like currently working on the Azure ML platform. That's about me. So I'll start with a small project that I worked on during my internship at Blue Canoe Learning. So basically, Blue Canoe Learning is a B2B startup that helps like non-native English speakers improve their English pronunciation. So they kind of use a very innovative technology to work with teaching pronunciation, which is called color vowel system. It's backed up by a lot of research, so you can like read more about it. But basically, I'm going to focus on the machine learning aspect of it, which I worked on during my internship. Okay, so basically the problem statement that we were trying to solve was, so non-native speakers have this problem of substituting B with V and V with B, and similarly L with R and R with L. So these kind of problems are prominent amongst Mandarin and Spanish speakers. So I have a small example of the audio that we were kind of working with. So here you'll see the B to V substitution very
Some of
clearly.
us are going to the movies.
So if you heard that, the person said some of us are going to the movies instead of movies. So that's a problem problem with Mandarin speakers. And here is a example of L to R substitution.
Please introduce yourself to our staff during the call.
So as you must have heard, she said, please introduce yourself to our staff during the car instead of the call. So we were trying to identify these kind of mistakes in our speakers so that we could give them like live feedback that you replaced a V with B or with a L with R. So to solve this kind of problem, the solution that I proposed was, so basically we were going to gather some training data. So the training data was basically audio recordings from native speakers so that we could have a benchmark model that could compare non-native speakers to native speakers, because we'll assume that Native American speakers are always correct in pronouncing a V as V and a L as L or R as R. So our training data basically comprised of all native speakers. And then we did some data processing to basically get the slice of audio recording that just had V part of it or B part of it, because we were not interested in any other phoneme or letters here. So that's what we did. We sliced our data to just get B's and V's from that. And from that, we extracted our features. So basically, in the world of speech, we have some very important features like MFCCs, delta MFCCs, delta MFCCs, and formats. I'm going to be explaining about these features in the next slide. But for now, you can assume these are the feature set that we had. And once we had the features and our labels, so our labels were like B or V, whether the user spoke B or V. And the feature set included all these. And then we trained our model with these features. And I'm going to be talking about the models and how we evaluated the models in detail later. And then we had to work on how to productionize the model. So by productionizing, I mean how to integrate the model with our current app. For like when a user comes in and practices a sentence, we give them real-time feedback on it. So, and after productionizing, we had to test it in real time, like how are the users liking the feedback and if the feedback is right or wrong. So this is what our machine learning pipeline looked like. Okay, moving on to the data preparation. So I'm going to be walking you through each of these boxes one by one. So for data preparation, we used a publicly available speech corpus, which is called Libri Speech. So Libri Speech is basically 560 hours of native speech spoken. Um, so, and for phoneme alignment. So by phoneme alignment, I mean just getting the slices of audio which has B or V in it. For that, we use Pocket Springs. So Pocket Springs is basically an open source speech recognition toolkit by Carnegie Mellon that helps you in aligning the speech with the time of the letter when it was spoken. So it will just give you like B was spoken for 1 millisecond from 203 to 204. That would help us in slicing those audio recordings. So once we have the timing information, we slice the audio recordings to get all the B's and V's spoken. And after all this manipulation and yeah, after preparing the data, we had like 10 million spoken B's and V's with their labels. So this is what this is all about native speech, because right now we are trying to create a benchmark model against which we can compare our non-native speech, right? So yeah, then moving on to feature extraction. Like I told you, we used MFCCs, delta MFCCs, delta MFCCs, and formats. So MFCCs are basically like components of audio signal that help you identifying the linguistic content. It helps you discard like all other background noise, emotion, because a person, if he's angry, might have a higher pitch of B versus a person who's just like in a normal mood. So it helps you filter out all that information. And delta MFCCs and delta MFCCs are nothing but just first and second derivatives of MFCCs, and they help you capture the trajectories of MFCC over time. And formants are basically like concentration of acoustic energy like around a signal. So basically like F0 is the pitch of your voice, and F1 to F3 are different like frequency bands in a signal. So just to make it easier, I'll show you a picture of how a data sample would look like. So yeah, so like in a signal, these are the formats, all these red lines that you see. So these are basically some numbers that we are trying to extract from a speech signal. F0 is the pitch, which is the lowest red line that you can see. And then there's intensity. So like when you calculate all the MFCCs, delta MFCCs, delta MFCCs, and formats, they give you about 44 features for a audio signal. So that's what we had, about 44 features in our data, and our label was B or V. I tried and fit a couple of models because it was a classification problem. So I started with a very basic logistic regression model. Then I moved on to a decision tree, random forest classifier, SVMs. So after like comparing all the baseline models uh, and their accuracies, I found that random forest classifier had the best accuracy with our feature sets and labels. So once I figured out random forest was quite good, I tuned my random forest classifier using grid search to further improve the accuracy. And at the end of the project, like I had about 97% accuracy on my validation set. So the main reason that we wanted to have a higher accuracy on this model was because we are training our data on native speech. So we would assume that it's like, it should give you 100% accuracy. So the higher the accuracy, the better would be the model for sure in this case. So once we had our model trained, we used this model as a benchmark to compare the speech of non-native speakers against native speakers. Okay, and then moving on to model testing. So model testing was quite of a challenge in this case, because so the basically like to get the accuracy for non-native speakers is a very difficult thing, because we had like about 10,000 recordings in our database, and we had to go and listen to each of those recordings to get a true label for them, because we don't really know whether the non-native speaker has spoken a B or V. So I did this myself. I listened to like 2,000 recordings per day, every day, and labeled it so that I could get a true measure of my model accuracy on non-native data set. So at the end of the project, after I had done like manual recording, manual labeling, I also went ahead and created a Node.js tool to run like randomly selected 10,000 recordings through my model to check whether I was getting the same kind of accuracy that I had just tested earlier. And then, so basically like in any machine learning model problem, I think the main challenge is to decide on a right metric to evaluate your model on. Like accuracy is for sure one of the measures, but in our scenario we also wanted to minimize the false positives. Now why false positives? Because users are coming to learn English on our platform, right? So we do not want to demotivate them and like give them wrong feedback. So we wanted to minimize a false positive just to ensure that we are not like giving any wrong feedback. We might miss a mistake here and there, that's fine. But instead of like giving a wrong feedback to user, we would prefer missing out some feedback. So we try to minimize a false positive. And these are some of our results. Like if you see when the user spoke actually B versus predicted B, when actually it was B and the user spoke it as V, and other like all the basically this confusion matrix helps you understand how our false positives are. And then, so in the production environment, like especially in Blue Canoe, we had two environments. One was like a development environment and one was production environment. So in development environment, only a very few users had access to it, because they had signed up for like helping us training our new machine learning models. So we tested that model in development environment for about 15 days before deploying it to production. And once we were sure that the model is not like giving very weird feedback or recommendations, we went ahead and deployed it to production. That's about model training. Now comes the software side of it, where we had to integrate our model with the current architecture of Blue Canoe backend. So in Blue Canoe, we majorly used AWS for our backend infrastructure. So this is how our machine learning model architecture looked like. So these are all the classifiers that we had, like LR classifier to detect L2R substitution, a BV classifier to detect B2V or V2B substitution, and other classifiers like that. So basically this symbol is, there's something called lambda functions on AWS. So for now, you can just assume it's just a function that takes an input and gives you an output. So when a user comes in and speaks something on our app, the first function that is called is phoneme alignment, so that we can get the start time and the end time of each of the phonemes, like B or V or L or R. And once we have the start time and end time, we have a machine learning model coordinator. All the start time and end time is passed through this function. And then this function calls each of the classifiers depending upon the situation. For example, some sentence might not contain a B or V at all, or L or R at all. So this function decides whether to call B or V classifier or L or R classifier or both. So, and it also passes the start time and end time as an input to these functions. So like, for example, my BV classifier is called. So when it is called, it will be called with the start time and end time of BV. And then this Lambda function would slice my recording and send the sliced recording for prediction to my model. And within that period, even feature extraction would happen. So basically this function would contain a slicing function, a feature extraction function, and a prediction function. So once my predictions are done, I will send my output to a common place from where like all the software side can pick up the output of my model and give the feedback to the user. So this is how our architecture looked like. And some of the challenges that we faced while working on this model was one, like I mentioned, testing the model was a big challenge because with non-native speech, we never had true values for our recordings. So we had to go and manually label each of those recordings. And second challenge was, I'm not sure if everybody would be familiar with this, but AWS Lambda functions have size limitations. So you can just deploy 2 GB of your model data and including everything should be just 2 GB. So for that, like for example, I used a package called Librosa to extract my features, but it's a very heavy package, Python package, which has dependencies on NumPy, Numba, and other packages. So that didn't work at all. To solve that problem, I had to look at the backend code of Librosa and extract my features like using no other dependencies. Like I just used the math that Librosa had used and extracted my features. So I just used NumPy to extract my features. Like I had to write all the mathematical calculations myself. And the third problem that we faced was, so Lambda functions have an initialization problem, like they have high latency when they are in a rested state. So for example, my first user comes at 4 o'clock in the morning. And before that, I've had a rest period for about 2 hours. So Lambda would take some time to give some predictions. So the initial set of users might face a high latency there. So for that, what we did was we created another Lambda function called a warmer function, which would just ping all our machine learning models randomly at every 5 minutes. So even when we had no users coming to our app, that function would keep our Lambda functions warm. So that's what we did to solve this problem. And that's how our latency of prediction was also reduced. Yeah, that's how we solved the machine learning problem that I just spoke about. So in case you have any questions about the machine learning model, I can take them right now before we move on to the interviewing tips.
I have a question about the labeling, because
Sure.
In a word, first of all, as you said, you need to recognize the word, and then after you need to identify when the sound is supposed to come. So like, how exactly did you do the labeling, and were you like actually spotting like on the diagram where the V started and the V ended? How did you do this feature kind of extraction manually?
Sure. So I'll start with the labeling question. So for labeling, so our audio recordings are basically like one sentence recordings, like please introduce yourself to our staff during the call. That's one sentence. And we also have the transcript associated with each of the audios because it's a fixed set of sentences that we ask our users to like speak out so that we know what feedback to give them. So once we have the transcript and the audio recording, we just had to listen to the whole audio recording by ourselves. Like there is no get around that. So you like once you have the transcript, you know which of the word has B or V. So you pay special attention when the user is speaking that word. So sometimes you might need to listen to the recording again and again. Yeah, but
Okay.
that's
So that was pretty, I imagine, long. And then after in the word, how do you like, was it the model or some function that identified when the B or the V was being pronounced? Because as the person is not pronouncing the right sound, how do you know what frame it is to, what time frame it is for that letter?
So for that, we, like I mentioned, we used open source tool called Pocket Sphinx. So basically that's kind of how speech to text engines work, right? Like even when you're talking to Alexa or Google Home Mini, you might say it wrong, but they kind of understand you correctly. Like Google Home Mini or Alexa understands speakers from various different regions with various different primary languages. Like Hindi speaker or a Mandarin speaker would not speak the same way as an American speaker. So that's how speech to text engine works. So there's like a lot of math behind it, but they use hidden Markov models, and these days they're using a lot of deep learning techniques to basically understand the start time and end time of a word.
Okay,
And
so that was pre-trained models you were using.
yes, yes.
Okay.
So we use something called pocket springs, but there are other technologies available for that.
Okay, thanks.
Any other questions?
I have a question. So you're saying you are deploying the model on the AWS, right, and using the Lambda. So is that a serverless model? So did you encounter any challenges when deploying it on AWS, aside from configuring the environment and stuff like that?
One of the major challenges of AWS Lambda function is the size limitation. They do not let you upload like everything packed with the environment. It has to be about 2 GB. So you cannot use like PyTorch or TensorFlow, which are heavy dependencies. So you have to try and minimize your package dependencies of your model. So for that, like I mentioned, I wrote all the feature extraction code from scratch rather than using a library. That's one of the biggest limitations. The other limitation of Lambda function, like I mentioned, is lazy initialization problem. If a Lambda function has been in rest for about 2 to 3 hours, it will take some time to warm up. So for that, we introduce another Lambda function called a warmer function, which would just ping all other Lambda functions at every 5 minutes to ensure that it's always in like working state.
Oh, okay. Yeah. Thanks.
Yeah.
That answers my question.
Any other questions?
Okay.
Okay, I think then we can go forward, and later if they have questions.
Sorry, I had a question, but I was muted. Did you ask for user feedback to like kind of validate the accuracy of your model?
Yes. Like I mentioned at the beginning, like we had two environments for our for productionizing our model. So first we deployed our model to the test environment or development environment, where we just have a few set of users who are ready to give feedback to our models. And we are also in the development environment, so we also get to test our models there. So yeah, we did test our model for about 15 days in the development environment, where we would just like me and my team would go on and speak in a wrong way, right way. We'll try everything possible to check if the model is giving right predictions. And we would also look at like the probability of the prediction. And that's how after testing the model for about 15 days, we decided on a threshold as well. Like, for example, if the probability is above 80, only then we would give the feedback to the users, otherwise we wouldn't. So yeah, we did do the testing in development environment for about 15 to 20 days. But
and after, did you collect feedback once it was in production? Did you like set a mechanism to get real user feedback to improve the model?
Yes. So in AWS, there's something called CloudWatch dashboard, where you can go and see like all the predictions that have happened with the model. So when any user came in, we kept checking like whether they were given a feedback like they replaced B with V or B with V. So we would look at the probabilities value. I would download the recordings, listen to them for a couple of days. Yeah, it's a very tedious process, but with speech, the thing is, there is currently no like automated labeling tools. With speech, you have to go and listen to the recordings yourself.
Okay.
Yeah.
Thank you.
Yeah.
Hi, I have a question.
Sure.
Hi, Aditi. Thanks. First of all, thanks for being with us today. My question is that you said you used the random forest, but I'm just like, how about the artificial neural network? Like probably, I've seen something kind of similar maybe for extracting the MFCC using the browser or something like that, and they were using artificial neural network. Is it the same thing, or probably it's kind of something different?
So basically, if we would have gone ahead and used ANNs, it's not with the feature extraction that we would use ANNs. Librosa is just a package to extract MFCC's formats and other features. But once we have the feature set ready, we can use artificial neural networks for prediction, whether the user spoke B or V. So we could have gone ahead and used artificial neural networks, but I wanted to take it slow. This was my first project in my internship. So I started with basic machine learning models just to get an understanding of how speech world works. But like in the subsequent projects at Blue Canoe, I did use neural networks because they were just a very small team and they were just starting out, so there was no ML team in place. I was like the first one who went ahead and made some machine learning models for them. So I started with machine learning and then I moved on to neural networks in my subsequent projects. But yeah, for sure you can use neural networks here.
Thanks.
Any other questions?
I think you're good.
Okay. So I would just walk you through some basic tips that I followed to get a job in the US and like how to break into data science ML field. So one thing that is very important here is networking. So like I had come here from India, and in India we don't like have so much of networking going on around. So this is one thing that one has to pick up once you're in US. So by networking, I mean like you have to know what's happening in the field, because data science and machine learning, AI, everything is growing so fast that it's difficult to keep a track of everything that is happening around you. So one thing that you can try and do is, so these are all just personal suggestions. You can go ahead and try something different and do share with me if anything works. But these are my personal suggestions. So follow like all AI ML leaders on Twitter, LinkedIn, because like they share what's happening in their companies or in the field. Like for example, I follow Yoshua Bengio or Yan Likun on Twitter, Facebook, and LinkedIn. So I get to know what's happening in Facebook and other companies. That's just a good way to know the latest developments. And then there is something called Meetup here in US. So if you join like different machine learning groups here, you have different meetings happening and you can connect with people there. Like I went to a Google Dev Summit through a Meetup group and I met a lot of interesting people who were working on TensorFlow back then. So yeah, that's a good way to network. And on LinkedIn, you can just like randomly connect with people who are working for companies you're interested in, and you can go ahead and ask them about your work. So when you're just connecting with people on LinkedIn, just try to be cautious that you're not spamming them with your requests. Like when you're sending them a request, try to leave in a small note saying why you want to connect with them and what are you looking to get from them. So yeah, send a note when you're sending a request, LinkedIn request. And then there are various machine learning conferences happening around the world. Try to attend them. That again helps you understand what is happening in the MLDL world around you. So some of the conferences are very expensive, and I understand everybody cannot afford it, but there are free conferences also happening. Try to register for them and attend them. And also like with the paid conferences like Grace Hopper, you have a lot of scholarships going on which you can apply for. So you basically have to write a statement of purpose explaining why you want to attend the conference, and you can easily get a scholarship to attend those conferences. So try to attend at least 1 or 2 conferences during your graduation period, or like whenever you're looking for a job. Second most important, this is like the most important thing, is competitive programming. There is no escaping data structures and algorithms at all. Like the first round of interview will always be a coding round. So people who are not from coding background, like I myself had never done data structures algorithms back in India. This was the first time I was experiencing it. So please like do it every day. Just don't escape it. Even when you're on a vacation or something, just try to look at a question on LeetCode, HackerRank, everywhere, and try to think about it throughout the day and code it out at the end. So initially, like you might feel that you're not able to solve. So you can go ahead and look at the solution, but ensure that when you go back to writing it, don't see it and write it. Just like write it without seeing it. And eventually you will have to challenge your brain to like think about the solution yourself instead of like looking at the solution every time. So yeah, do practice lead code, HackerRank, whatever platform you like. So one approach that worked for me was like in lead code, you have explore cards explaining each data structure, and there are some questions around that data structure. Like there's a explore card for arrays, then strings, then graphs, trees. So like that kind of helped me structure my learning because I wasn't aware of these data structures before I came here. So do that. And then there is a very good platform called Pramp, where you can go ahead and give like mock interviews for your data science interviews. So like you'll have a person who will be interviewing you, and you'll also have to interview that person. So that kind of gives you a good environment to interview people and get interviews. So like when you are interviewing people, you know how people answer, and then you know that you might also answer the same way. So just like that, that's a very good platform to develop that skill of getting interviewed and interviewing. So go ahead and practice interviews there. And the third thing that is very important is like do some projects on machine learning and AI. Like you might take a course on Coursera or like anywhere, but that's not going to help. Like certificates do not help. You need to do things like by yourself, because in interviews, you'll mostly be asked very applied questions. They won't ask you like, what is a batch norm or what is CNN? They'll ask you, when you did this project, how did you solve this problem in this project? So like pick up a topic of your choice. If you like NLP, vision or speech, try to skim through different research papers on that topic. Pick up some problem that excites you. Like for example, during my graduation, I worked on a project called for voice authentication, because I always felt like asking, like when you enter your passwords on Facebook or anywhere, it's kind of tedious. Instead of that, if I could just say unlock my Facebook account, that would be more helpful. So I picked up a project on voice recognition and then voice authentication. And then once I had picked up that project, I went and looked for research papers on that topic, and it exists. So research is in like all fields already. You just need to find the right space for you. And once you have the research paper, implement it end to end, because there is some math in the paper, then there's some implementation details. Until you write the code, you have not done the project. So implement it end to end and then put it on your GitHub. That would help a lot for sure. And then the last thing that is very important is reading. Like read research papers, Medium blogs about the product for the company that you're interviewing for. Because like in data science interviews, it's not like a software development interview where you just be asked coding questions. Companies want to know if you can apply your ML, DS skills to solve their business problems. For example, for an Airbnb interview, all my interviews were around how could I solve their business problems using my DS skills. So until and unless you know the product well, you cannot crack the interview. So read like tech blogs of like all these companies have their tech blogs on Medium, Netflix, Airbnb, Microsoft. So go ahead and read them. Read research paper. Like these companies also publish research papers in NIPS and other ICML and other conferences. So like keep yourself up to date, and especially when you are like in the interviewing phase, like when you have like 2 weeks of time left for an interview with Netflix, just like read whatever Netflix has written around machine learning and AI or whatever. That would help you like answer your questions better in the interview. Yeah. So these are some tips that I had for like cracking data science interviews. But in case you have any questions, I'll be happy to answer them.
Thanks. It is really helpful. Any questions?
Jay, you're currently working at Microsoft, right?
Yes.
And so what are you doing on what type of business issues are you currently working?
So I'm working on Azure machine learning platform. So basically machine learning platform on Azure is like a drag and drop model space where a user can come in and like they can drag their data into the UI, and then they can drag the kind of model they want to build. And when they connect those two components, the model is trained itself. So I'm currently working on the backend side of it, wherein we are trying to like program how each component would interact with one another. So rather than a business problem, you can think of it as like a product backend. Right now, I'm trying to develop that machine learning platform to work better for the users. So for that, like we are kind of working on like how continuous integration and delivery would work for machine learning models, and how like the same model can be used across different business spaces. For example, we have insurance clients, pharmaceutical clients, um, like online grocery stores coming in. So we want our model to work for each of those businesses, irrespective of like how their data is. So we're kind of working on generalizing those models right now.
I have a question, Aditi. Thank you so much for your talk. My question is that you were working for ML role and also DS role. I'm just wondering that what's the difference between these two roles? I mean that what's the difference between these two one?
Okay, so data science is more concerned with just like preparing your data and training your model, whereas machine learning roles are more towards like software side of data science. So you also have to work on like making your model work for a large scale application. Like you have to also work on productionizing your model. And productionizing means like if you are productionizing a model for Facebook, you want it to work for millions and billions of users. So you also have to look like how fast your predictions are, what's your latency time for prediction, like, and whether like this model would not crash for a large scale of like users. So it's more towards like software side of machine data science. And whereas data science is just like data preparation and then model building. You do not have to be like concerned about how users are going to be interacting with your model.
Okay, okay. All right,
Yeah.
thank you.
Other questions?
I have something to say, but it's not really a question, but it's a remark that I made to myself, and I would like you to say your mind about it. It seems to me now that nowadays in companies, being a data scientist is not enough. You need to be a software engineer plus a data scientist. You need to be able like to know how to deploy your model and to find the best architecture. Knowing you really have a deep knowledge of algorithms is, of course, is a highly valuable skill, but I'm afraid that this is really not enough for firms today. So that was my point. That maybe you have different minds. I don't know. Yeah.
I wouldn't completely disagree with your point, but the thing is, there is no like set definition for DS and ML roles right now in the market. So like there are different like for example, some DS roles just make you do like dashboarding and reporting. So there is no like set definition for any of these like business analyst, data science or ML roles right now. You have to look at the job description of the role that you're applying for, because not all roles require you to have like productionizing skills or productionizing skills. So there are a lot of roles in Amazon which require you to have some experience with productionizing your model, but there are many roles that just ask you for just basic machine learning knowledge. So there is, just don't like have that hard set boundaries of roles in your mind right now. Just like keep looking for different roles, look at their job description and apply. And if a company wants you to have some productionizing experience, that's not a very difficult thing to get. Like you can just pick up any cloud platform like Azure or AWS or anything and try deploying a model. It's a very easy thing to do. Like you can read the documentation and just follow the steps there. So it's not a easy, not a difficult thing to put it in your resume. And also like you mentioned that it's the companies are looking for it and they want you to have it. I don't think I've had that experience personally, because I've given some interviews where the skill was valuable and other interviews where this skill was not even asked for. So you should probably look out for different roles around and read their job description and apply accordingly.
Thanks for that answer.
Other questions?
I have a more general question about the speed at which technology is going for speech in speech recognition and machine learnings around speech. It looks like there's a lot of processing, transforming into image, and then after going for different kinds of models. Do you see some breakthroughs like on the audio files analysis, or are there some like interesting stuff you would recommend we look about? Because so far it looks like it's pretty tedious and the labeling is really like terrible. So how do you see that evolving?
I think that's evolving pretty fast, because with Alexa in picture, Amazon is doing some great work in speech recognition. And like recently, Facebook has also launched a model where you do not need to do any feature extraction or labeling. You can just pass in your raw audio files to the model and it will give you a speech to text work. Like it's a speech recognition engine. So it will give you a speech to text of the audio signal. So yes, there are a lot of things happening and it's getting easier and easier. So in case you're interested in exploring more about speech, go to Facebook's research blogs and you'll find some great things happening where you do not need to like do all this, what I mentioned just some time before. And also like Alexa has some great research papers that you can go through. Like
Okay.
you should, I would suggest you start with all these big companies and the research blogs, because they are doing the cutting edge work right now.
Okay, thanks. So we just like type research blog Facebook and we'll find the platform. Okay, cool.
Like also if you're following Facebook on LinkedIn, you do keep getting like suggestions on these papers, because that's how I come to know about these.
Thanks. Thanks a lot.
Okay, so I think any questions? If not, we will thank Aditi for today's invitation talk. Is really insightful and helpful. Okay, I think it's really a great time to have you here, and I hope I wish you all success in your career, and then probably we'll see each other in the future. Thanks a lot.
Thank you, Aditi. Thank you very much.
Thank you.
Thank
Feel
you a
free to
lot.
connect me on LinkedIn in case you have any more questions. I can answer them.
Great.
Thanks.
Thanks a lot. Bye.
Bye.